Hi, in this video, we're going to explain the genetic algorithm. First, we start by generating the populations, giving a range or a size, and in each population, we decide how long the gene of each individual is going to be. After that, we define the fitness function that is only the sum of the individual values. In this case, I'm going to use a gene length of 20. And by this fact, we are going to have the max sum of an individual to be 20. After defining the fitness, we select a parent that goes by creating a tournament and selecting a sample of multiple individuals on the list and determine the best individual of each tournament by its fitness and returns the best individuals into a new matrix. By having the surviving individuals after each tournament, we cross over the parents of new new population, and we do this by giving some of the values of parent one and parent two to two different childs, and these childs are now the new generation that evaluates again after a mutation that is given by a random value in a range that I will decide also. So by having each of the functions, we go in that order. We generate the population, we evaluate the fitness of each individual, then we have the tournament to define the parents, and with the parents we create childs that have a chance to mutate, and then we repeat. By doing this, we create a new generation that has to be formed by the best possible solutions. In my case, the population size will be 80 uh, individuals. The gene length of each individual will be a 10 parameter, and we're going to repeat the generation 40 times, and we're going to make the mutation a little bit higher by giving it a 5% rate. And now we check the results, and we have our 40 generations. We can see that we start in our first generation with our fitness level being 17, and after that we go higher, and at one point every single individual is in a fitness level of 20, so we get a perfect individual. If we choose a higher gene size in a smaller population with the same rate, we can. Okay, so if we have a bigger gene length and a smaller population and smaller generations, we can see that the value of the fitness level fluctuates between 60 and 50, and at the end we get a 62, far from the perfect gene length. If we make a smaller gene length and smaller generations, and we increase the rate to something like 75, we can observe that the fitness level stays approximately in a average. That's all. Thank you.